This is the Quandary. So a cart is going some speed at the bottom of a hill, right? And it's moving some speed. So here it is. Let's draw a little picture here. Right? 345 kilograms. We're going to exert some force for 3.4 meters, right? Forces we don't know. It is moving at the bottom of the hill, 8.5 meters per second. And we want to give it a boost so that when it gets to the top of the hill, okay, it is going 4.8 meters per second. So presumably that speed is, these are, hold on.
No, not it.
He is in my A-Day class. She's not in the class anymore.
Okay.
Nathan's here. Kelsey's in my A-Day class.
Okay.
Yeah, there we go. 1, sadly. Here we go. Are those like little love notes or something? Okay, so presumably, by the way, the cart, if had it coasted up the hill, how high is the hill? 5.3 meters. Had it coasted up, it either would not have made it up the hill or would have been going slower, yeah, than that, if we're going to give it a boost, right? So what does it have here? I think it doesn't have potential. I think it's got kinetic, right? Right? He meant to say, but he didn't say, right? Now, there's a force and a distance. Wow. There's a force and a distance overtly mentioned. Is it speeding us up or slowing us down? If it speeds us up, it's on the left side. If it slows us down, it's on the right side. I think this one's speeding us up. It's an asset, right? So it's plus force times distance, right? And then I don't think there's anything else. There's no springs. It's not on the top of a hill. In fact, it's at the bottom, right? And then what does it have at the top? Kinetic and potential, right?
Oh, no.
All right. No. Oh, these are room 30.
This is room 30, is it not?
37.
Dang it.
So you want to go to this room that's 7 more. I just thought. It's right across the hall, but you know. Okay, so at the top it's got mgh plus 1/2 mv squared. Yeah, doesn't it? And we know that because it's on a hill and it's moving. We're like having a hard time, right? Okay. And now we're all set. Are we all set? We can just plug numbers in. So 1/2 345 times 8.5 squared plus some force times 3.4 is 345 times 9.81 times 5.3 plus 1/2 345, and then we know the velocity 4.8, right? Yeah. And the only thing we don't know is the force. Yeah. If it was slowing you down, like if there was a retarding force or something like that, or friction force or something. So any force that slows you down is going to be an expenditure. It'll be on the right side. Hey, at the assembly, did they have like a piece of glass inside that hoop for the first like 30 seconds of that minute? It's like, honest to God, I'm sitting next to Osborne, like every shot is like missing, right? And then suddenly we start hitting them, right? But it was like, there was this period of time, right? That's hard though, right? It's an assembly.
What was all saying?
You're not warmed up, what?
What was all saying?
He just said, oh, geez. I think it was the only thing I could quote. Which wasn't, no, I'm just kidding. That was kind of fun. Seriously? I think he said just, he was like, because we all gave him a hard time about that. Okay. 345. I'm solving here. With my calculator. Yeah, I get that.